A patch of northern Minnesota woods usually looks like a static environment of trees and dirt. However, the topography and stones here hold a physical history that dates back hundreds of millions of years. Most of us walk over these landscapes without noticing the evidence of massive planetary changes buried just inches beneath the topsoil. In this specific yard, there are deep trenches running perfectly parallel to the walking trails. Scattered nearby are gray stones with circular holes, and others featuring repeating geometric patterns that look entirely biological. These objects represent 3 different eras of the Earth's history. By looking at the physical characteristics of the land, we can reconstruct the exact sequence of events that created this property. Recognizing these physical signs makes it possible to see the local soil as a chronological archive. The most recent evidence is found in these deep, uniform troughs. They run alongside the wooded trails in long, straight lines. When builders first cleared these paths, they faced a recurring engineering problem, routing a flat trail down a slope and across a wet, lowland swamp. To solve this, they used borrow pits. They excavated dry earth from the immediate sides of the trail and piled it in the center, creating a raised land bridge that stayed above the water level. Those parallel trenches are the permanent physical results of that construction. They are the empty spaces where the path's foundation used to be. While these trails were built just decades ago, the stones resting inside the trenches are products of a much older event. The gravel in this yard is a jumbled mix of quartz, basalt, and stones known as omars. These rock types rarely form in the same geological environment. This mixture is glacial till. It was deposited during the last ice age, when a sheet of ice over a mile thick covered this entire region. The glacier acted as a continental bulldozer. The moving ice sheet scraped up bedrock from northern regions and dragged it hundreds of miles south. This explains the Omarolics, or omars. These stones originated in the Belcher Islands of Hudson Bay, Canada. The ice carried them across the border and dropped them here in Minnesota. An omarolic forms when nodules of soft calcium carbonate are trapped inside a harder rock called greywacke. When the ice melted, acidic groundwater flowed over the stones. The soft calcium dissolved and washed away, leaving the hard greywacke with perfectly smooth circular cavities. This scattered gravel is a collection of Canadian bedrock carried south and deposited by the melting ice. Some of the stones in the yard show even more intricate patterns, including repeating honeycombs and ribbed circular indentations. These unique specimens are biological marine fossils. Hundreds of millions of years ago, this area sat near the equator and was covered by a warm, shallow tropical sea. This is favosites, or honeycomb coral. Each of these hexagonal pits was once the home of a single coral animal, which worked in a colony to build this structured framework. The rocks with ribbed holes contained crinoids, or sea lilies. These animals had a long stalk made of stacked mineral discs. When the animals died, their stalks fell into the mud, leaving behind these ribbed molds when the organic material dissolved. This means the lowest layer of the property was originally formed on an ancient ocean floor. The landscape is built from 3 distinct eras: the tropical sea that left the fossils, the glaciers that moved the Canadian stones, and the human construction of the trails. All 3 faces stack vertically in the forest floor. Tree roots push through human fill and glacial boulders to reach ancient marine bedrock. Physical evidence of these global shifts is accessible in the topsoil of a standard residential lot. By actively observing the dirt and the local rocks, we uncover a specific history for every topographical ridge. The ground is a physical log of seabeds, ice sheets, and human engineering.